So reverse engineering is a process of expanding our understanding about the objects themselves. It's a process which lets us analyze structured objects, but also the unstructured ones as well. And really its ultimate goal is to translate as many unstructured objects back to their original definitions, back to their structure defined as a structured object. So ultimately describing their form into something that a reverse engineer can understand. We call structured objects formats, and that's referring to either file formats or messages. All of them have structure which is meaningful to the reverse engineer. And reverse engineers really do manual work in investigating what an object ultimately is doing. They look at its code, they look at its data, they try to describe its algorithms with the whole purpose of understanding, is this object going to have a negative effect on my organization? And the reason why reverse engineers exist and why they do what they do is to bridge that gap and to identify threats even before security solutions have a chance to do so. In fact, security solutions, based a lot of their detection capabilities based on the work provided by reverse engineers and threat analysts. So the idea is to be able to define the threat in a way a machine can then recognize. And regardless of that being a signature or a machine learning algorithm, a reverse engineer is always involved. They're either a part of creating that pattern which identifies the file, or they're labeling the data set and saying, okay, so this file is malicious because it's trying to do these things. And even those labels can be expanded into, this is a specific type of a threat, this is ransomware, or this is a remote administration tool, or anything that might harm the organization. So they're really necessary to help us understand what an object is trying to accomplish. A lot of what they do is manual. And when I say manual, it doesn't really mean, poking at the machine with fingers. It means using tools which they have at their disposal. But these tools don't really do the whole analysis task for them. They're really like a screwdriver, if you will. So when you're thinking about reverse engineering tools, you're thinking about tools like a hex editor, right? Which is really trying to display the raw content of that object. So bytes and sequence of bytes which define what an object is. Then those bytes get translated into structure. And that's what the format is, what a structured object is, something which has form. If the object itself has code, there's other tools which lets us investigate the code itself. So yet again, translating those bytes into instructions that a processor is actually executing. So tools like that are called disassemblers, and they're letting us inspect the actual code of the application. And you're looking at it from a static analysis standpoint, just like text on the screen or a text in a document, and you're trying to read through that text to understand what's going to happen when that program gets executed. In essence, that's what static analysis is all about. As opposed to that, there are other tools which we call debuggers, which lets us execute that code and even step through those lines of text one at a time. And while we're doing that, we're observing the behavior of the application. All of these tasks, as I said, are manual, and that's where reverse engineers take their expert knowledge, they apply it to solve that problem, solve the puzzle of what the actual application is going to do. That takes quite a long time. Analyzing any application can take hours, days, or weeks, depending on how complex that application is. And that might be a time-critical task. The analyst or reverse engineer should come back with an answer relatively quickly, because business decisions need to be made whether or not part of that system needs to be taken offline is largely correlated to what type of a threat the organization is trying to fend off. And to solve that problem, we've turned to automation, really, because there's only so many reverse engineers out there, and there are necessity to defend the organization. Automation is the key, and automation provides us with the answers, with really quick answers of what the actual application is trying to accomplish if that application was to be executed. We can even monitor its behavior and then reason about all the effects that application might have. And that's where really we're not trying to substitute a reverse engineer or its role, we're trying to enhance it and expand the reach a reverse engineer has within the organization. So from a single object, and then a reverse engineer might have analyzed per day, we're going into tens and hundreds and even thousands of objects which might be analyzed if augmented with automated processes.